What is the air quality index?
The U.S. Environmental Protection Agency, EPA, developed the Air Quality Index as a measure to better advise citizens of pollutants in the atmosphere. To calculate the index, the EPA takes into account levels of carbon monoxide, ozone, nitrogen dioxide, and sulfur dioxide. Each pollutant is measured in parts per billion and compared to an acceptable standard over a certain period of time. 24 hours for most pollutants, but ozone is calculated over an 8-hour period. This number is then multiplied by 100 to give the air quality index. In other words, the formula would be pollutant concentration, / pollutant goal concentration, x 100 equals air quality index. The table below explains the different categories in the index.
How many active volcanoes are there?
Currently, there are somewhere between 850 and 1,500 known active volcanoes on our planet. There are 63 active volcanoes in the United States, mostly in Alaska, Hawaii, and in the Pacific Northwest. At any given time, about 10 or 12 volcanoes are erupting planet-wide.
What kinds of courses should I take at the university level?
For a more generalized career in meteorology, such as weather forecaster. A broad course in meteorology at the undergraduate level will prepare you well to continue on to graduate school. If you are particularly interested in detailed work in atmosphere science, you would be wise to earn an undergraduate degree in chemistry, physics, mathematics, or engineering. The growing field of environmental and climate research offers opportunities to meteorologists who also have an educational background in fields such as biology, ecology, oceanography, and geophysics. To increase your chances of finding a job at a professional level in meteorology, you will need at least a master's degree, and a doctorate is often preferred.
When was the first official storm warning issued in the United States?
Professor Increase Lapham, working with the U.S. Signal Corps, issued the first severe storm warning in America on November 8, 1870. The warning concerned a storm that was building strength in the Great Lakes.
Who was Alexander Buchan?
The most prominent meteorologist of the 19th century, Scottish scientist Alexander Buchan. 1829 to 1907, is sometimes referred to as the father of meteorology. He is credited with making great advances in weather charts, including his use of isobars to connect areas of equal pressure in lines that are now familiar to anyone who has seen a weather map. He also understood the importance of ocean and atmospheric circulation like no one else of his age. In his 1868 book, Handy Book of Meteorology, he made long-range weather predictions, the first person to do so in a printed publication. Among his most famous ideas was what are now called buck and spells. These are predictable blips, abrupt changes in temperature in the usually smooth transition in weather between the seasons. For instance, he predicted that a cold buck and spell typically occurred the week before Valentine's Day. Buchan was wise enough, though, to know that such a rule could never be hard and fast, and admitted that his buck and spells allowed for some variations and sometimes never occur at all.
What are cooling degree days and heating degree days, and what do they have to do with air conditioning?
Utility companies in the United States use the term cooling degree days to refer to the number of days when it is likely that air conditioners will be turned on, and heating degree days to determine when furnaces are likely to run. Because it would be impractical to visit every home and business to see whether the air conditioner or furnace was running, utility companies assume that customers are most comfortable when the temperature is 65 degrees Fahrenheit, 18.3 degrees Celsius, and that they will run their air systems accordingly. A degree day is not actually a 24-hour period. Rather, it is a measurement of the difference between the optimum of 65 degrees Fahrenheit. Fahrenheit is used as the standard because it is a US system, and the mean, average, temperature of a particular day. So, for example, if the mean temperature in Dallas, Texas, on a warm July day is 85 degrees Fahrenheit, the utility companies will count that as 20 cooling degree days. 85 degrees Fahrenheit, 65 degrees Fahrenheit equals 20 cooling days. The states with the most annual cooling days on average are Florida, Texas, Arizona, California, and other southern states that, on average, rack up about 4,000 cooling days annually. Heating degree days use the same concept to calculate furnace use. As one might imagine, northern states log more heating degree days than southern states.
What is a nor'easter?
A nor'easter is a storm along the eastern coast of North America that affects the region, with northeasterly winds with speeds up to 75 miles, 121 kilometers, per hour or more. Such storms evolve when low-pressure systems accumulate humid air from the Atlantic Ocean or from the Gulf of Mexico, and combine it with cold dry air coming down from Canada in conjunction with a strong jet stream. The system rotates counterclockwise, bringing strong rainstorms in the south and, in winter, snow to the northeast. Nor'easters have wreaked havoc on the United States a number of times. For example, a February 1969 nor'easter dumped 70 inches, 178 centimeters of snow on Rumford, Maine, and 164 inches, 416.5 centimeters, on Pinkham Notch, New Hampshire. One of the worst nor'easters resulted in a superstorm in March 1993 that is still referred to as the storm of the century.
Is there much permafrost in the lower 48 U.S. states?
There is no permafrost in the lower 48 states. Those states such as North Dakota and Minnesota do often experience conditions where frost levels penetrate the ground to depths extended 30 or more inches, 76 centimeters.
What is more dangerous, a big tornado with a funnel spanning over a mile in diameter? Or a narrow, speedy tornado?
Either one can be equally dangerous. Many factors are involved when considering how lethal and destructive a tornado may be, including how fast the vortex is spinning and how much debris is being blown around.
Who was named the United States' first official meteorologist?
James P. Espy, 1785 to 1860, was most noted as the author of The Philosophy of Storms, 1841. A year after this book's publication, the U.S. Congress named him the federal government's meteorologist. He is credited with giving the first accurate description of how thermodynamics plays a role in cloud formation, also explaining the dynamics of low-pressure systems.
Does global warming increase the incidence of diseases?
Warmer temperatures tend to encourage pests to flourish. This includes everything from insects and rodents to viruses and germs. Mosquitoes, which are responsible for killing more human beings than any other animal on the planet because they spread disease through exposure to blood, thrive nicely in hot to temperate climates. Their breeding cycles become shorter, which allows them to reproduce more frequently each year. Mosquitoes spread diseases such as malaria and dengue fever. Rodents, carrying disease-spreading parasites like fleas and ticks, also spread their ranges as climates warm. The problem is multiplied by the fact that along with global warming comes drought, flooding, and famine, which lead to poverty, homelessness, and unsanitary water supplies. All of these encourage unsanitary living conditions that help spread diseases, such as cholera. According to a 2008 statement by the World Health Organization, about 150,000 people are dying every year from malnutrition. Diarrhea, and malaria, much of it provoked by climate change. Hardest hit are poorer countries in Africa and Southeast Asia.
How does a lightning rod work?
Invented by Benjamin Franklin, 1706 to 1790, around 1750, the lightning rod is designed to provide lightning bolts with a safe path to ground the electricity so that it does not damage a building. Lightning rods have actually become a bit more important to have on a home or other building in recent years, because the metal pipes that used to be installed for indoor plumbing and that could serve as lightning rods are being replaced by non-conductive PVC pipes.
Does it have to be raining for there to be lightning?
There needs to be a storm for there to be lightning. But it does not have to be raining in the same location for lightning to occur. Lightning strokes have been observed as far away as 10 miles, 16 kilometers, from where rain was actually falling. And lightning strokes may happen as much as 10 minutes after all rain has stopped.
What is an acoustic shadow?
An acoustic shadow is kind of like a mirage, only involving sound instead of light. Differences in temperatures at varying atmospheric layers causes sound waves to refract or bend. Also, wind shears and the absorption of sound on soft surfaces can contribute to the effect. The result can be that sounds coming from a particular source might not be heard by someone standing fairly close by, while other people located farther away, but in a direction where sounds are being refracted, can hear the sound. A famous example, the consequences of acoustic shadow, is often cited from the U.S. Civil War. During the 1862 Battle of Seven Pines in Richmond, Virginia, Confederate General Joseph Johnston told his commanders that, upon hearing gunfire from soldiers being led under Major General D.H. Hill, he would order Brigadier General W.H.C. Whiting to send in an attack on the Union's flank. However, because of acoustic shadow, Johnston was unable to hear the battle noise and the flank attack was not sent in when it was needed. The Confederates subsequently lost the battle.
Why does the Earth's orbit change from circular to elliptical over time?
Like all the planets in our solar system, our world is subjected to the gravitational tugs of not only the Sun, but all the other planets as well. We know that our moon causes tides and other gravitational effects that we can see every day. But Earth's orbit is also influenced by the gas giants Jupiter and Saturn. These planets are big enough to pull Earth's orbit out of shape as they circle the Sun. Then the Sun's gravity eventually pulls it back again in an extremely slow tug of war.
What is the Saffir-Simpson hurricane scale?
The Saffir-Simpson Hurricane Damage Potential Scale, which is the full name, is a 5-point scale invented in 1971 by engineer Herbert Saffir, 1917 to 2007, and Robert Simpson, 1912, a hurricane expert. Rating hurricanes on a scale of 1 to 5, with 1 being the weakest and 5 the strongest. The scale ranks these storms according to peak wind speeds and the amount of damage they cause.
What is a meteorite?
A meteorite is a large particle from outer space that lands on Earth. They range in size from a grain of sand on up. About 30,000 meteorites have been recovered in recorded history. About 600 of them are made primarily of metal, and the rest are made primarily of rock.
How thick is Earth's atmosphere?
Earth's atmosphere extends hundreds of miles beyond its surface. But it is much denser at the surface than at high altitudes. About half of the gas in Earth's atmosphere is within a few kilometers of the surface. And 95% of the gas is found within 12 miles, 19 kilometers, of the surface.
What kinds of courses should I take at the university level?
For a more generalized career in meteorology, such as weather forecaster. A broad course in meteorology at the undergraduate level will prepare you well to continue on to graduate school. If you are particularly interested in detailed work in atmosphere science, you would be wise to earn an undergraduate degree in chemistry, physics, mathematics, or engineering. The growing field of environmental and climate research offers opportunities to meteorologists who also have an educational background in fields such as biology, ecology, oceanography, and geophysics. To increase your chances of finding a job at a professional level in meteorology, you will need at least a master's degree, and a doctorate is often preferred.
What was Snowball Earth?
Scientists now believe that at between 2 to 4 times between 850 and 580 million years ago, the planet was covered completely in ice and early life forms were nearly wiped out, a snowball Earth. There are a couple of theories as to why this occurred. One being that the Sun was about 6% cooler than it is today, the other is that the continents had All traveled due to plate tectonics, mostly south. Ocean currents traveled easily around the planet without interruption, and volcanic activity dwindled to a minimum. The result was that significantly less carbon dioxide was being generated and expelled into the atmosphere. In addition, the Earth's axis was significantly more tilted at the time. By 54 degrees versus today's 23.5 degrees, causing more drastic seasonal extremes. Once a period of cooling began and ice shelves formed, more of the sun's light was reflected, thus causing the cooling cycle to accelerate more and more until everything was frozen. Early theories about this, proposed by such scientists as George Williams at the University of Adelaide and Joe Kirschvink at the California Institute of Technology, include the effects of plate tectonics as causing massive volcanic eruptions worldwide. This would lead to an extended winter of unprecedented scale that turned Earth into one big frozen lump in space that would last for millions of years. Nearly all life was wiped out. In fact, one matter of debate concerning this theory was that critics felt such a snowball Earth would have extinguished all life. This notion was laid to rest in the 1990s when life was found to thrive near geothermal vents deep under the ocean. The snowball Earth cycle was only broken because volcanic action and plate tectonics would cause carbon dioxide levels to build under the ice, especially since there would be no liquid water to dissolve minerals or aid in the dissipation of CO2 levels. The result would be an inevitable, sudden massive release of CO2 that would lead to a comparatively brief period of extreme heat with temperatures averaging 120 degrees Fahrenheit 50 degrees Celsius. However, the thaw retreated to another snowball period a couple more times over millions of years, before the continents moved into positions that created a more stable geophysical state of the planet. Volcanic activity moderated, as did carbon dioxide levels. Another snowball Earth could happen again, however, as the continents, hundreds of millions of years from now, drift back together to form a new supercontinent.
How much does the entire atmosphere weigh?
If you were able to take all the gases in the air and place them on a scale, the total weight would be 5.1 quadrillion tons, 5.1 x 1015 tons, or 4.63 quadrillion metric tons.
What is the World Meteorological Organization, WMO?
Because the weather is a matter of international concern affecting all the world's countries. The WMO is a highly valuable organization that promotes the sharing of meteorological data between nations. Formerly the International Meteorological Organization, EST 1873. The WMO was created in 1950, the next year, it came under the aegis of the United Nations. The WMO is interested in severe weather forecasting and in the impacts of Human activities on the environment that affect the climate and weather.
Where is the most humid place on Earth?
In terms of highest dew point temperatures, the extreme is found along the coast of Ethiopia along the Red Sea. Here, the average afternoon dew point in the month of June is a staggering 84 degrees Fahrenheit, 28.9 degrees Celsius. Tropical rainforests the world over, of course, are known for extremely high humidity.
How fast does rain fall?
The speed of rainfall varies with drop size, wind speed, and the size of the raindrops. A typical raindrop in still air falls about 7 miles, 11 kilometers, per hour. Large raindrops can reach speeds of 16 to 20 miles, 26 to 32 kilometers, per hour. While the tiniest drops are slower than a mile, 1.6 kilometers, per hour as they drift to Earth. Thus, the larger drops can usually splash onto the ground about 3 minutes after being generated in a rain cloud that is about 5,000 feet, 1,500 meters, above the surface.
During what part of a thunderstorm's duration is there the most risk of being struck by lightning?
Statistics show that more people are hit by lightning strokes toward the end of a thunderstorm. This is not because there is more lightning at that time, but rather because people get too anxious to go outside before the storm is completely over.
Are there trees that predict the weather and tell time?
Observing the leaves of a tree may be an old-fashioned method of predicting the weather. But farmers have noted that when maple leaves curl and turn bottom up in a blowing wind, rain is sure to follow. Woodsmen claim they can tell how rough a winter is going to be by the density of lichens on a nut tree. Before the katydid awakes, a black gum tree is able to indicate the oncoming winter. Trees can also be extraordinary timekeepers. Griffonia, in tropical West Africa, has 2-inch, 5 centimeter, inflated pods that burst with a hearty noise, indicating that it is time for farmers of the Accra Plains to plant crops. Trichilia is a 60-foot, 18-meter, tree that flowers in February and again in August, signaling that it is time, just before the second rains arrive, for the second planting of corn. In the Fiji Islands, planting yams is cued by the flowering of the coral tree.
Who managed to calculate cosmic ray activity on Earth dating back over 11,000 years?
Sami Solanki, 1958, an astronomy professor at Germany's Max Planck Institute. developed a method for estimating solar ray activity dating back millennia. Solanki based his method on the knowledge that cosmic rays create chemical reactions in the atmosphere. One byproduct of these reactions is carbon-14, which then precipitates down onto the Earth's crust. Trees and other vegetation absorb this radioactive form of carbon. Preserved vegetation that has been buried underground for centuries can be dug up and its composition analyzed. Radiation from sunspots actually decreases the production of carbon-14, and so when sunspot activity is high, there is less carbon-14 for trees to absorb. Using this information, Solanki discovered that there has been more sunspot activity since around 1930 than during any other period going back 8,000 years.
How was the jet stream discovered?
With the advent of airplanes that could cruise at elevations of over 30,000 feet, over 9,000 meters, high, pilots such as World War II bomber pilots flying over Japan and the Mediterranean Sea discovered the effects of the jet stream on their aircraft.
How much pressure does the atmosphere exert upon us?
Average air pressure is 14.7 pounds per square inch, 1.03 kilograms per square centimeter, at sea level. Measured in inches of mercury, this comes to 29.92 inches, or 1013 millibars. To put it another way, a cubic yard of sea level air weighs a bit over 2 pounds. About 0.7 kilograms per cubic meter.
What causes deep ocean currents to flow around the world?
The deep ocean currents are driven by thermohaline circulation, which is movement caused by differences in the temperature and salinity content of the water. Because cold, salt-laden water is heavier than warm water, it sinks to the bottom of oceans. To replace it, warmer water fills in, and as it subsequently cools, the rotation is repeated. This constant movement of water has often been referred to as a giant global conveyor belt or pump that slowly circulates water all over the world's oceans. For example, the warm Gulf Stream current is heated by the sun, starting in the Caribbean. It then flows north along the east coast of North America, mostly along the United States coastline, until it reaches subpolar waters in the North Atlantic. Between Greenland and Norway, the cold Arctic winds cool the salt-laden water almost to the freezing point. Huge amounts of the now cold, heavy salt water sink at this point to depths of around 3 to 4 miles. 5 to 6.5 kilometers, and begin the next phase of the journey. Traveling southwards through the western Atlantic basin to the Antarctic circumpolar current, and then into the Indian and Pacific Oceans. This trip takes many years. Off the coasts of Peru and California, For instance, upwellings often consist of ocean waters that sank to the depth centuries before.
What is the difference between absolute and specific humidity?
Absolute humidity given in grams per cubic meter is the amount of water vapor in a cubic meter of air. Specific humidity is the amount of water vapor per gram of air.
What is the Doppler effect?
The Doppler effect refers to the way sound and light waves behave. Depending on the motion of the transmitting and receiving objects. As objects move away from each other, waves become stretched out. And as objects move toward each other, waves become compressed. When it comes to sound waves, the result is that one hears a higher pitched sound if an object making noise comes closer. If that object is moving away, the result is a lower pitched sound. When it comes to light waves, compressed visible light is shifted toward the blue spectrum, while it is red shifted if objects are moving away. Astronomer Edwin Hubble, 1889 to 1953. Used this information about light waves to form his theory of an expanding universe. The Doppler effect gets its name from Austrian physicist and mathematician Johann Christian Doppler. 1803 to 1853, a figure in history whose real name has caused considerable confusion. His baptismal certificate indicates that he was actually born Christian Andreas Doppler. But on his gravesite his name is presented as Christian Johann Doppler. Depending on sources, he has also been cited as Christian Andreas Doppler and Johann Christian Andreas Doppler. Let's just go with his last name. Interestingly, the Doppler effect was not confirmed by its theorizer. Rather, it was a Dutch scientist named Christoph Hendrik Diederik Buys-Ballot, 1817 to 1890. Who proved it by conducting an experiment in which he was trying to refute Doppler's theory. Buys-Ballot set up a series of trials by a railroad track in Utrecht, the Netherlands. An accomplished horn player rode a train while a second highly trained musician stood by the tracks. Listening to the first musician play a note on the horn. After 2 trials called on weather. A third trial confirmed that Doppler was correct about how sound waves change with motion.
Can you see a tornado using Doppler radar?
No. Doppler radar can tell meteorologists if conditions within a storm are favorable for tornadoes such as strong winds and cloud rotation, but it can't actually see a tornado.
Why do clouds float?
Cloud droplets are, actually, subject to the Earth's gravity, and so they do, in fact, fall. They do so very slowly, however, and are subject to winds and air pressure that keep them aloft. When not being blown about, cloud droplets descend at a rate of about 30 feet per hour.
Do hailstones have rings?
Yes, but unlike with trees, the rings do not indicate the age of the hailstone. Italian physicist Alessandro Volta, 1745 to 1827, did a study in 1806 to analyze the bands. He concluded that hailstones, before they fall to the ground, may change elevation a number of times due to up and down drafts. As the temperature and moisture levels change, layers of ice accumulate on an embryo nucleus, at different rates, thus forming the layers.
What is the moist tongue?
Sometimes meteorologists come up with some pretty fanciful descriptive terms. Moist tongue falls into that category. It refers to humid tropical air moving in the direction of either the North or South Pole. A moist tongue regularly occurs in the spring and summer over the U.S. Central Plains, where it works in conjunction with a jet stream to produce storms.
If ozone is good for us, why do we hear about ozone alerts and bad ozone?
Ozone is great when it is high up in the atmosphere and doing its job of protecting us from radiation. But when it is down near ground level, it is toxic to those who breathe it in. Car exhaust fumes and other sources of pollution include ozone, which is seen in smog. Ozone pollution can make people sick and damage crops. Small amounts of ozone are also produced by electrical storms. If you have ever performed electricity experiments in a high school or college laboratory, you might be familiar with the ozone smell produced by even small bolts of electricity.
Who discovered how rainbows form?
In 1304, a German Dominican monk named Theodoric von Freiburg, 1250 to 1310, showed that light passing through a large glass globe filled with water would create a rainbow because light waves were bent through refraction, reflection, and dispersion. He speculated that the same process occurs in raindrops, creating natural rainbows.
What is a state climatologist?
A state climatologist is a professional in the field who has been designated by a state government or agency of the state as the state's official climatologist. They must also be recognized by the National Oceanic and Atmospheric Administration and by the Director of the National Climatic Data Center. Currently, 48 states have a state climatologist, the exceptions being Tennessee, Rhode Island, as well as Washington, D.C. Also climatologists have been designated for Puerto Rico, Guam, and the U.S. Virgin Islands. State climatologists are supported by the American Association of State Climatologists, which was founded in 1976. State climatologists receive their salaries either from the state or from a university. And they also work closely with the National Weather Service.
What is the story behind the man who lent his name to the Humboldt Current?
Next to Napoleon Bonaparte, Alexander von Humboldt, full name, Friedrich Wilhelm Heinrich Alexander Freiherr von Humboldt. 1769–1859, was largely regarded as the most famous man in Europe in his day. Educated in everything from finance and languages to astronomy, geology, and anatomy, Humboldt had a passion for science and travel. Most notable was his voyage to South America, 1799 to 1804, during which he explored the natural landscape, making observations about the animal and plant life, as well as geological and astronomical observations. From this experience, he originated the idea that species vary depending on the climate, which varies with temperature and elevation. He also correctly surmised volcanoes probably align themselves along geological fissures in the Earth's crust. Humboldt connected the dots between geology and weather, noting how climate changes with elevation. He also was the first to observe how the Earth's magnetic field varies with latitude, and made observations that would later contribute to theories on how weather systems are generated with the planet's middle latitudes. When Humboldt's expedition reached the Pacific, he discovered the Peru Current, which is now also known as the Humboldt Current. For all his explorations and discoveries, Humboldt became a hero when he arrived back in Europe. He wrote about his journeys in the epic 30-volume work The Voyage of Humboldt and Bonpland, 1805 to 1834, and was even more lauded for his 2-volume Cosmos, 1845–1847, in which he attempted to unify many scientific disciplines to describe the complexity of nature as a whole system.
How fast do hurricanes travel?
A typical hurricane will travel across the ocean at a speed of about 250 miles. 400 kilometers per day, or about 10 to 15 miles, 16 to 24 kilometers per hour. They have been known, though, to advance at speeds as fast as 60 miles. 96.5 kilometers per hour, which was the case during the New England hurricane of 1938.
When did maps displaying cold and warm fronts first get published in the United States?
Although the discovery of weather fronts was made during World War I, it was not until the 1930s that U.S. weather maps began to use symbols to indicate them.
What is the National Climatic Data Center, NCDC?
Part of the National Oceanic and Atmospheric Administration, the NCDC serves as a vast archive of meteorological data called the World Data Center for Meteorology, which it then provides to various agencies, organizations, publications, insurance companies, and law firms all over the planet. Records go back as far as the 19th century, and include data ranging from modern radar and weather balloon reports to observations made by ships over a century ago. The Meteorology Data Center is located in Asheville, North Carolina. The NCDC also runs the World Data Center for Paleoclimatology in Boulder, Colorado.
What causes a tornado?
Scientists still do not fully understand how a tornado forms and why. The general theory is that tornadoes form from cloud systems that are slowly spinning. Usually in supercell storms, but weaker systems can produce them as well. The current belief is that a mesocyclone within a storm system is surrounded by pronounced variations in air temperature and downdraft. However, tornadoes have been known to form in cloud systems where strong winds and variations in temperature do not exist. Once a funnel begins to form, however, it can gain speed and strength in much the same way as ice skaters gain rotation speed as they pull their arms close to their bodies.
What is the effect of a microburst on aircraft?
Microbursts are downbursts of air with a diameter of 2.5 miles, 4 kilometers, or less. Often associated with thunderstorms. They can generate winds of hurricane force that change direction abruptly. Headwinds can become tailwinds in a matter of seconds, forcing aircraft to lose airspeed and altitude. After microbursts caused several major air catastrophes in the 1970s and 1980s. The Federal Aviation Administration, FAA, installed warning and radar systems at airports to alert pilots when conditions were right for wind shears and microbursts.
Wasn't 2008 one of the coolest years for the United States?
Yes, for the United States the 2008 temperature averages were the lowest since 1997. Also, precipitation was way up that year, which, along with it being a La Nina year, is a primary reason why meteorologists believe it was a considerably cooler season. The average temperature from January to October 2008 was 55.9 degrees Fahrenheit 13.3 degrees Celsius versus 55.7 degrees Fahrenheit 13.2 degrees Celsius. In 1997. This made 2008 actually a fairly average year with regard to records kept over the last 114 years. However, global temperatures were the ninth highest on record in 2008.
How does the wind chill factor affect temperature?
Also known as the wind chill index. It is a number that expresses the cooling effect of moving air at different temperatures. The National Weather Service began reporting the equivalent wind chill temperature, along with the actual air temperature, in 1973. For years it was believed that the index overestimated the wind's cooling effect on the skin. A new wind chill index was thus instituted in 2001, and other adjustments have since been made, too.
What should I do when a tornado approaches?
Try to get to the lowest level of the building, unless you are in a mobile home or outdoors. In which case you should seek a sturdy and safe shelter. Many mobile home parks have a centrally located tornado shelter these days. Go to the center of the room and hide under a sturdy piece of furniture. Stay away from windows, hold onto the leg of a table or something else stable. And protect your head and neck with your arms. If your home has a basement, take shelter there. If not, interior bathrooms are usually the sturdiest rooms in a home. And you can protect yourself further by climbing into the bathtub.
How many people are killed in the United States by lightning?
The U.S. total from 1959 to 2003 is 3,696 deaths. About 60 people die each year from lightning, about 300 are injured annually. The highest death rates are in Florida, 425 killed between 1959 and 2003. Making it the most dangerous state to live in when it comes to lightning injuries. Below is a state-by-state listing using the most recent data from NOAA.
What are evaporation and transpiration?
Evaporation, as many people know, is what happens when liquid water changes to a gaseous state, escaping into the surrounding atmosphere. The rate of evaporation can be measured using an evaporimeter. Transpiration refers to the release of water vapor from plants, but can also refer to perspiration and sweat being lost from humans and animals.
What is sea level air pressure?
The air pressure at sea level averages 29.92 inches of mercury, or 1013.25 millibars, MB. No matter what their elevations, weather stations calculate barometric pressures in their area according to what they would be at sea level. In this way, reports remain consistent everywhere.
Is the greenhouse effect a good thing for life on Earth, or bad for the environment?
Like so many things about life on Earth, moderation is the key. Some greenhouse effect is a very good thing for life on Earth. Without any such effect on Earth, the oceans would eventually freeze. If the greenhouse effect increases significantly, however, many living organisms and species, as well as environmental systems that have developed over a long time, including human civilization, will face substantial challenges, and possibly even extinction. In the most extreme case, a runaway greenhouse effect like that on the planet Venus would cause all life on Earth as we know it to cease to exist. On the other hand, many plants will benefit from increases in carbon dioxide levels, warmer temperatures, and longer growing seasons.
What is the largest known meteorite to strike Earth in the past 100,000 years?
About 50,000 years ago, a metallic meteorite about 100 feet, 30 meters, across crashed into the Mogollon Rim area in modern-day Arizona. It disintegrated on impact, creating a hole in the desert nearly a mile across and nearly 60 stories deep. Meteor crater, or the Barringer meteor crater, as it is more commonly known today, is a remarkable and lasting example of the amount of kinetic energy carried by celestial objects. Just the lip of the crater rises 15 stories up above the desert floor. For a long time, scientists puzzled over the origin of this crater. It might have been volcanic in origin, they thought. But geological evidence, such as shallow metallic remnants in a huge radius miles around the crater, confirmed it was a meteorite strike.
What is the Landsat program?
In 1972, NASA launched the first Landsat, land satellite, in cooperation with the U.S. Geological Survey, while taking photos and measurements related to the planet's surface. These satellites also provide a considerable amount of weather-related information. For example, Landsat satellite data has recorded the impacts of weather disasters, monitors flooding, and takes other measurements of interest to hydrologists. Recent surveys of land use have also resulted in studies about the effects of human activities on weather. For example, In 2006, an atmospheric modeling study was conducted on the state of Florida. Scientists compared estimates of vegetation coverage in the year 1900 with present conditions and demonstrated how urban and rural activities were affecting rainfall. It was estimated that Florida now experiences 12% less rain than it would have a century ago.
What can I do to help relieve frostbite?
First of all, if you feel you are suffering from frostbite, you should seek professional medical attention while trying to keep pressure off of extremities, fingers and toes, that have been frozen. You should never vigorously rub the afflicted area, as this could cause severe tissue damage or even break off pieces of tissue. If you are unable to see a doctor immediately, a warm bath. Have the water between 100 and 110 degrees Fahrenheit 38 to 43 degrees Celsius, is a much better choice than sitting in front of a fireplace.
Are there any other tornado strength scales in use?
Yes. In Great Britain, meteorologists use the TORO, the Tornado and Storm Research Organization scale, which is divided into T0 through T10 measurements of strength. A T0 tornado has winds beginning at 40 miles, 64 kilometers, per hour. An AT10 is a super tornado with wind speeds of 270 to 299 miles, 435 to 480 kilometers, per hour.
What is acid fog?
Acid fog is just like acid rain. When sulfur dioxide is present in the air, it can be captured by water vapors of all sorts, including fog. If this weren't bad enough, acid fog tends to be much more acidic than acid rain, up to 10 times as acidic. This acid fog, which can linger in the air for hours or even days, can be as bad as walking through clouds of floating vinegar and is very destructive to plant life, as well as building materials ranging from iron to concrete.
What is the sunburn index?
The sunburn index, which is also known as the UV index, was developed by the National Weather Service and the Environmental Protection Agency as a way to provide people with information as to the varying risks of sunburn on particular days. Ranging in scale from 0 to 10, 10 being the riskiest, the index is calculated based on several factors: day of the year, latitude, elevation, cloud cover, and ozone levels. People with fair skin should be the most cognizant of the UV index when venturing outside, though people with tan or dark complexions should not ignore it either. The table below explains the index in more detail.
What is the AMS Seal of Approval program?
The AMS seal of approval is given to forecasters in the media who provide useful and accurate information about the weather. Part of the intention here is to recognize broadcast meteorologists who do more than just read National Weather Service copy on the air. The seal, therefore, is a service to audiences so that they may discern whether they are receiving their information from a certified professional, or simply from a news reader. A meteorologist may receive a seal either in radio or television broadcasting. They are eligible for the seal based on the quality of the information they provide, their professionalism, their demonstrated effort to continue their education in the field, and their participation as an AMS member. Their qualifications are reviewed by a certifying board committee. Finally, the seal is not bestowed permanently, but must be renewed annually.
What was the solar neutrino problem?
From the very beginning of neutrino astronomy research, there was a discrepancy between the theory of nuclear fusion and the number of neutrinos detected from the Sun. Neutrino telescopes on Earth detected only about half as many neutrinos as they should have. This strange result was checked again and repeatedly confirmed. This became known as the solar neutrino problem.
Who else formed theories that ice ages occur in cycles?
Before Milankovic, French mathematician Joseph Hadamard (1797–1862) published his book Revolutions of the Sea in 1842. In it, he suggested ice ages occur in 22,000 year cycles that matched the precession of the equinoxes. Scottish geologist James Crowell, 1821–1890, later elaborated on this theory. However, scientists did not know enough about the history of ice ages to compare this theory with actual data. And so the hypothesis languished for another century.
Was the 2005 New Orleans disaster caused by a flood or a hurricane?
The initial cause of the disaster was Hurricane Katrina, which whipped up tides and sea water against a very fragile levee system that protected New Orleans. The city is 49% below sea level, and so when the man-made levees broke, flood waters moved in and inundated much of the city.
What is a cloud?
Clouds are collections of trillions of rain droplets suspended in the atmosphere. These droplets consist of water or ice crystals that condense around a nucleus, usually a dust or other small particle, such as pollen, volcanic ash, mineral flakes, or other organic or inorganic materials. To form, clouds require air that has cooled to the point where the air is saturated with moisture or ice crystals. In other words, when the humidity reaches 100%. Each cloud droplet is only a few micrometers in diameter, and it takes a million such droplets to form a single raindrop.
What is the Fata Morgana?
This fantastical mirage gets its name from Italy, where this particular type of superior mirage is frequently seen in the Strait of Messina between Sicily and the Italian mainland. Named after the Arthurian legend of Morgan le Fay, who tales tell had a palace beneath the sea. This optical illusion occurs when light diffraction causes distant buildings to appear vertically stretched and, thus, more like castles.
What is light pollution?
While not harmful to people or other living things, light pollution is an annoyance to astronomers. Light from cities makes it difficult to see stars and other heavenly bodies at night, which is why observatories are stationed on top of mountains and hills outside of urban areas. It is also why space observatories such as the Hubble telescope are so important for astronomers.
What is clear ice?
Clear ice, as the name suggests, is clear, amorphous ice forming on surfaces as a result of water drops falling and freezing when the temperature is between 27 and 32 degrees Fahrenheit, -3 to 0 degrees Celsius.
Am I getting hit by cosmic rays?
Everyone is being struck by cosmic rays all the time, probably about several each second. Ordinarily, the number of cosmic rays that strike you have no negative effect on your health. Even though the energy of these particles is very high, the number of them striking you is relatively low. If you went beyond Earth's magnetosphere, though, your health might be at risk. On Earth's surface, the magnetosphere acts as a shield against cosmic rays by redirecting them toward Earth's magnetic poles. Thousands of miles up, however, the cosmic ray flux on your body would be much higher, and thus cause potentially more damage to your body's cells and systems.
Who created the first anti-air pollution law in Western history?
England's King Edward I proclaimed in 1306 c. that coal burning was to be restricted while Parliament was in session. The penalty for violating this law was rather harsh by today's standards, death.
Is Earth's atmosphere changing?
Earth's atmosphere is continually and gradually changing. Over cycles that usually last many thousands of years. The concentrations of different gases including oxygen, carbon dioxide, and others go up and down. As does the concentrations of tiny dust particulates such as carbon soot. In the past 100 years or so, human population growth and industrial activity has caused a much sharper change in the concentrations of some gases and particulates on a much shorter time scale than at any time in the past 200,000 years. The most dramatic effect has been a huge increase in the amount of carbon dioxide in the atmosphere. This increase has created a substantial greenhouse effect. According to some scientists, which could be increasing the average temperature on Earth at a much faster rate than typical ecological and geological time scales.